Good morning, everybody. How's everybody doing? I hope you're doing well. I'm looking outside and there's some sunshine, so I'm doing pretty well. So, I'm going to do an example of a calculation that the next time I see you, each one of you is going to do in class. You're going to do different numbers, but each one's going to do about the same calculation. So, there's a table that you're going to have, and we're going to fill out the table, and I'm going to do the first row of the table. So, I have a 1 kilogram cart moving at 9 meters per second, and a 0.5 kilogram cart moving at negative 6 meters per second. And I'm going to assume after the collision that the the 1 kilogram cart is moving at 4 meters per second. So, first it says how much mechanical energy does the cart system have before they collide. So, in this case, the mechanical energy that they have is kinetic energy. So, I have to calculate the kinetic energy for each one and add them together. So, that would be 1/2 the mass of the 1 kilogram cart times the velocity of the 1 kilogram cart squared plus 1/2 the mass of the 2 kilogram or the 0.5 kilogram cart. I guess I should call it 0.5 kilogram cart times the velocity of the 0.5 kilogram cart squared. So now I just put in the numbers. 1/2 times 1 kilogram times 9 meters per second squared plus 1/2 times 0.5 kilograms times negative 6 meters per second squared. So when I do the math, I find that I have 40.5 joules plus 9 joules. So to begin with, my cart system has 49.5 joules. Okay. So then it says what's the velocity of the 0.5 kilogram cart after the collision. So we've done this. This is a collision. This is conservation of momentum because my system is the cart system. And yes, they are both interacting with the earth. And yes, they are both interacting with the track. But those interactions cancel out, right? So everything is in my system. So I have my 1 kilogram cart moving at 9 meters per second. I have my 0.5 kilogram cart that's moving at negative 6 meters per second. That negative is really important. Afterwards, I have my 1 kilogram cart that's moving at 4 meters per second. And my 0.5 kilogram cart, I don't know how fast that's moving. So my momentum is conserved. So the mass of my 1 kilogram cart times the velocity of my 1 kilogram cart plus my mass of my 0.5 kilogram cart times the velocity of my 0.5 kilogram cart equals the mass of the 1 kilogram cart times the new velocity of my 1 kilogram cart plus the mass of my 0.5 kilogram cart times the new velocity of my 0.5 kilogram cart. Now all I do is put in the numbers. 1 kilogram times 9 meters per second plus 0.5 kilograms times negative 6 meters per second equals 1 kilogram times 4 meters per second plus 0.5 kilograms times the new velocity of my 0.5 kilogram cart. So now let's do some algebra. 9 kilogram meters per second minus 3 kilogram meters per second equals 4 kilogram meters per second plus 0.5 kilograms times the new velocity. So that ends up being 6 kilogram meters per second minus 2 kilogram meters per second divided by 0.5 kilograms. That's the new velocity of my 0.5 kilogram mass, and that ends up being 4 meters per second. Then it says, what's the velocity of the center of mass? So the center of mass is where all the mass would be if I would take something and if I would make it small, small, small and put it into a dot. When we do a free body diagram, that's what the dot in the free body diagram means. So the center of mass is something that we really won't talk about very much, but it's interesting conversation here. So to find the velocity of the center of the mass, I find the mass of the first thing, the velocity of the first thing, plus the mass of the second thing, the velocity of the second thing, and I divide it by the masses. So in this case, my velocity of the center of mass is 1 kilogram times 4 meters per second plus 0.5 kilograms times 4 meters per second. That's what I just calculated. Divided by 1.5 kilograms. So the velocity of my center of mass is 4 kilogram meter per second plus 2 kilogram meter per second divided by 1.5 kilograms. So the velocity of my center of mass is 4 meters per second. A lot of 4 meters per second in this question. Then it says, how much mechanical energy does the cart-cart system have after they collide? So I need to find, again, the mechanical energy here is kinetic energy. So I need to find the kinetic energy. 1/2 times my 1 kilogram mass of my 1 kilogram cart times the velocity of my 1 kilogram cart squared plus 1/2 times the mass of my 0.5 kilogram cart times the velocity of my 0.5 kilogram cart squared. So I just plug in the numbers. 1/2 times 1 kilogram times 4 meters per second squared plus 1/2 times 0.5 kilograms times 4 meters per second squared. And that is 8 joules plus 4 joules. So that ends up being 12 joules. So I'm going to take these, I'm going to put them in the first column of that chart that you're going to have. And you guys are going to fill out the rest of the chart, and we're going to come up with some ideas about types of collisions. Hope you have a great sunny day.